Hello everybody, I got another lesson for you today. I want you to write down a couple vocabulary words here. Let's start with empirical formula. The empirical formula is the lowest whole number ratio of atoms in a compound. Do me a favor, write that down because I got another definition for you. And that is molecular compound. And what a molecular compound is, it's the actual number of atoms in a compound. Okay? What I'm going to show you how to do today is actually going to be this, our empirical formulas. Okay? I'm going to show you the steps on how you go from a percent composition to an empirical formula. And here's the key thing I want you to remember when you see a problem asking for an empirical formula. We don't care about grams this time. The unit that I want you to think of when you do this are your moles. Moles. I got a priest mole, which is a holy moly, and I got a cot mole, which is the patrol mole. When you think empirical formulas, I want you to be in the units of moles. Okay? And the last thing before I show you how to do this, when you come in tomorrow, I want you to try and fill in this blank before me. Okay? So write down this sentence and fill in the blank. Blank compounds are always signified as an empirical formula. You're going to have to look at the definition I just gave you, and there's something I taught you earlier in the year, and hopefully you can fill in that blank. Alright, let me show you how to begin. Okay, so let's go through the steps for writing empirical formulas. First, do me a favor, write down this I can statement. I can determine the empirical formula of a compound from its percent composition. And once again, I want to restate here that the key thing with this is you want to have the units moles. Get to moles. Wow. Alright, so here is the example we are going to use with these steps, and we're going to go along each step and I'm going to show you what to do. Now, I'm going to tell you there's nothing hard about any of this. The hard thing is remembering the steps to take, but nothing here is confusing in the least. So the problem has 25.9% nitrogen and 74.1% oxygen. We got to figure out what the formula is. So step one, don't even think about it. I want you to just change where it says percent right here and right here. I want you to change that to grams. Just go ahead and do that. And the reason why you can do this is you're assuming that there's 100 grams of the compound. And so think about it this way. If there's 100 grams of that compound in the question, then 25.9 grams of it will be nitrogen, and the other 74.1% of it will grams will be oxygen. So let's go ahead and just rewrite that. And that's step one, and it's that simple. Okay. Now, step two. Here's where we start getting into it. We're going to convert the grams of each of these elements to moles of those elements, because that's the key thing. We want moles. That's what we want. When we have moles, we have a formula. All right. So, 25.9 grams nitrogen. Convert that to moles, and you've been doing these mole conversions for a few days now. 1 mole of nitrogen is equal to 14 grams of nitrogen when you look at the periodic table. Cross out your units, divide those two numbers, and your answer is 1.85 moles. Of nitrogen. Alright, do the same thing for oxygen now.
And 1 mole of oxygen, when you look at the periodic table, is 16 grams. Sorry, I have a mistake here. It's not 7.41, it's 74.1. Sorry, make sure you make that correction. And then when you go ahead and divide these two numbers, it comes out to 4.63 moles of oxygen. Now, believe it or not, you actually do have a formula. It just won't look very pretty at all, not like you're used to. If I stop now and did a formula for this, my formula would be N 1.85 as my subscript to O 4.63. Okay? That's how many moles of each one of these we have in this compound. Okay? Thing is, you know enough to know that that's not how we do formulas in the least. So we're not done yet. We need another step here. So, step 3. Obtain the mole ratio of your formula and start this by dividing each mole value by the smallest mole value. Okay? This ensures that one of the elements starts with a mole ratio of 1. And we'll at least have one whole number in our compound. So here's what you do. You have 1.85 moles of nitrogen. You have 4.63 moles of oxygen. Which one of those two numbers is the smallest? Okay, we need the smallest mole value here, 1.85. So divide this by 1.85 and divide that by 1.85. Okay. And what you end up getting now is 1 mole of nitrogen. Okay. At least one of them has a ratio of 1. And this one right here ends up being 2.5 moles of oxygen. So right now, once again, we do have a formula, and it looks a lot better than the formula that we had right here. Okay, if you stopped at this point, you would have N1 O 2.5. Okay. But empirical formulas are the lowest whole number ratios. We don't like the 0.5 there. We want a whole number. Okay, so there's one more thing we have to do to convert this to an actual empirical formula. And that is step 4. If not all the ratios are whole numbers, multiply by the lowest number that will convert both to whole numbers. Okay. And here's what you need to think. This right here, 2.5. 2.5 times what number will get that to a whole number? Okay. And if you think about it, 2.5 times 2, take a look at this. 2.5 times 2 equals 0.5. Okay? That is the smallest whole number I can get there. What you do to one element, just like in math you do to the other, you got 1n times 2, you get n2. And so your final empirical formula, N2O5, looks very good. That's how we're used to seeing formulas. That is an empirical formula, the lowest whole number ratio of all the atoms in a compound. Okay. Now here's the thing. You went through this. None of the steps were hard. You just got to practice. And practice it enough so you know second nature what you have to do. Let me give you 2 problems that I want you to practice on. I need you to calculate the empirical formula of a compound that is 94.1% oxygen and 5.9% hydrogen. You may think that this will end up being water H2O, That is not the case. I will give you that hint. And then the second compound, I need you to figure out its empirical formula. 67.6% of it is mercury Hg, 10.8% of the compound is sulfur, and the final 21.6% of that compound is oxygen. Follow the steps I gave you, and you should find that it's pretty easy to come up with the correct answer.